Good afternoon, students. Welcome back to chemistry class. Today we are going to study about periodic trends in chemical reactivity. Very important. Listen carefully. Take notes. Okay. Periodic trends in chemical reactivity. Periodic trends in chemical reactivity. In last section we studied about the periodic trends in chemical properties. From that we have learnt about the valence electron in an orbital of an atom decide the chemical properties of an element. Valence electron only decide the chemical properties of an element. Okay, so here the periodic trends in chemical reactivity also decide the valence electron. Okay, so how the chemical reactivity vary along the periods and along the groups in a modern periodic table. Today we are going to study. Okay, what is the first point? The elements on the left side of the periodic table have less ionization energy and ready to lose electrons during chemical reaction. Okay, the elements on the left side. You know, this is the modern periodic table. Here, this is the left side of the elements. We called as the alkali metal group 1 and group 2 elements. We called as the left side of the elements. Okay, that is we called as the alkali. First group elements we called as the alkali metal. Second group elements we called as the alkaline earth metal. And right side of an element we called as the representative elements, or otherwise called as the p block elements. Okay, the elements present in the middle of the modern periodic table we called as the transition elements or inner transition elements. Okay, we know here the elements on the left side of the periodic table have less ionization energy. Ionization energy, what do you mean by ionization energy? The minimum amount of energy required to remove the valence electron. Okay, the minimum amount of energy required to release the electron from the valence shell of an atom. Okay, how many amount of energy we should give to remove the electrons? Okay, chemical reaction takes place by adding or removal of an electron. The chemical process is formed. Okay, so here ionization energy. Here we are going to study about how the ionization energy. Okay, the elements on the left side of the periodic table has less ionization energy. Okay, and ready to lose electrons during chemical reaction. We know left side of the periodic table group 1 elements and group 2 elements. Group 1 elements, what are the group 1 elements? Lithium, sodium, potassium, rubidium, cesium and francium. We know the lithium, what is the outer electronic configuration? 2s1, sodium 3s1, potassium 4s1, rubidium 5s1, cesium 6s1 and francium 7s1. Like that, the group 2 elements having the from 2s1 to 7s2. Okay, 2s2 to 7s2. From beryllium 2s2, magnesium 3s2, calcium 4s2, strontium 5s2, barium 6s2 and radium 7s2. Okay, so the alkali and alkaline earth metals, the outermost electron very less electrons are having the outermost orbital. Okay, so the first group 1 elements are very high reactive elements because only 1 electrons are present in the outermost orbit, so it is easy to remove the electrons. It is easy to remove the electrons from the outermost shell. Okay, because only 1 electrons are present here, so it is easy to remove the electrons from the outermost shell. Understood? So ionization energy very low. Okay, when we are moving right side of the periodic table, ionization energy very high because when you are moving from left to right, the electrons from the outermost orbital increased and it is difficult to remove the electrons from the outermost shell. Okay, the nuclear charge is increased, So high nuclear charge, it tends to pull the electrons towards itself. Because of this, it is difficult to remove the electrons from an outermost orbital. So high ionization energy need there, right side of the periodic table. Okay, in the case of left side of the periodic table, from moving from top to bottom, the alkali and alkaline earth metal, the distance from the nucleus and outermost orbitals are increased, so electrons are loosely bound. Okay, so there the nuclear force is very low on the outermost electrons. Okay, so ionization energy very less. What is the second point? The elements present in the right side have high electron affinity and readily accept electrons. What do you mean by electron affinity? Electron affinity means the amount of energy released by add the electrons in an outermost orbit. Okay, so when an electron remove, when removal of electron, we should give the energy. Okay, to addition of electron, we get the energy. Okay, to remove the removal of electrons from an outermost orbital, the atom need energy. To add the electrons in an outermost orbital, atom release energy. Understood? So electron affinity means the minimum amount of energy released when an electron is added to the outermost shell. Understood? So here the elements present at the right side of the periodic table. Right side, what are the periodic table or what are the elements are present? The right side, P block element. P block elements, representative elements. Okay, group 13 to group 18 elements. Group 13 to group 18 elements we called as the representative elements. Okay, here group 13 to group 17 elements or high electron negative elements. Okay, because it always attracts the electrons. It always attracts the electrons. Okay, because the outermost electron, for example, I am taking the oxygen and fluorine. I am taking the group 16 and group 17 elements. Group 16 elements, oxygen family. Okay, the oxygen family, oxygen atomic number 8, electronic configuration 2,6. Similarly, group 17 elements, I am taking fluorine, chlorine, bromine, iodine. I am taking one of the example fluorine. What is the atomic number fluorine? 9. Electronic configuration 2,7. Okay, so it always gain electrons, it always accept electrons to get the stable octet configuration. Okay, so the right side, the elements present the right side of the periodic table have high electron affinity because the nucleus, it always attracts the electrons. Okay, to get the stable configuration. So readily accept the electrons. So electron affinity very high. Okay, ionization energy very high. Electron affinity and ionization energy also very high. Ionization energy means the energy required to remove the electrons. Okay, so the right side of the periodic table, the elements, it is difficult to remove the electrons. Okay, remove the electrons. It is difficult to remove the electrons because the outermost orbitals having 6 electrons or 5 electrons or 7 electrons. Okay, so these elements, it always attracts the electrons, not remove the electrons. Okay, so when electron affinity, it is greater electron affinity means there is highly electronegative elements. Understood? And what is the third point? S and P block elements shows highly reactive than the elements present at the middle of the periodic table. Okay, what are the elements present in middle of the periodic table? Transition elements and inner transition elements. Okay, group 13, group 3 to group 12 elements we call as the transition and inner transition elements. Okay, these elements are present in the middle of the periodic table. Okay, so the S and P block elements. S block elements we call as, that is alkali and alkaline earth metal, and the P block elements, it is the right side of the periodic table. Okay, so these elements, when comparing the S block element and P block elements, the S block and P block elements are highly reactive than the middle elements present in the middle of the periodic table. Okay, the S block elements otherwise we called as the metals, and P block elements are otherwise we called as the non-metals. Okay, and the noble gas, the fourth point, the noble gas neither accept nor lose electrons and chemically inert. Okay, the noble gas neither accept nor lose electrons and chemically inert. Understood? What are the noble gases? We know group 18 elements we called as the noble gases. Group 18 elements we called as the noble gases. What are the noble gases? Helium, neon, argon, krypton, xenon, radon, and oganesson. Okay, so these elements we called as the noble gases because these elements have the stable electronic configuration. So it no need to accept the electrons and no need to remove the electrons. Okay, so it have, because it has the stable electronic configuration. Understood? These are about the chemical reactivity of the S, P and D block elements. Okay, then we are going to study about ionization energy and metallic character. The ionization energy is directly related to the metallic character. The ionization energy directly related to metallic character. How ionization energy related to metallic character? For example, the lower left of the periodic table elements, the elements present in the lower left portion, okay, left side of the periodic table have less ionization energy. Less ionization energy means, what do you mean by ionization energy? We know the amount of energy required to release the electron from the outermost orbit. Okay, so the elements present in lower left side of the periodic table, these elements shows less ionization energy because it is easily remove the electrons from the outermost orbit. Okay, so we can give very low energy. Okay, so this is the very less ionization energy. Okay, so very less ionization energy elements that shows the metallic character. Metals. Okay, metals means it easily remove the electrons. It easily remove the electrons. That is called the metals. Okay, in the case of the top right position of the periodic table, top right portion of the periodic table, that is called the non-metal because it has very high ionization energy. Okay, very high ionization energy because the outermost electrons, the electrons in outermost electrons are high. Okay, when moving from left to right in the periodic table, atomic number increases and electrons in outermost orbit also increases. Okay, so it is difficult to remove the electrons. Okay, difficult to remove the electrons in the outermost shell. So we have to give more energy to remove the electrons. So ionization energy high. Okay, so ionization energy high means that elements are metallic in nature. Non-metallic in nature. Okay, non-metallic in nature. Okay, so when metal easily lose electrons, that the elements easily lose electrons, we call as the metals. The elements cannot easily lose the electrons, we call as the non-metal. Okay, now we are going to study about how the reactivity of metals and non-metal and non-metal and non-metals. Okay, so for example, I am taking the left side of the periodic table. What are the elements are present? Hydrogen, lithium, sodium, potassium. Okay, I am taking sodium. When sodium it combines with oxygen, okay, sodium is the metal, oxygen is the non-metal. Okay, oxygen is the non-metal because oxygen present in the right side of the periodic table, sodium present in the left side of the periodic table. Okay, another one reason, the sodium atom, what is the electronic configuration? Sodium atom, atomic number 11, electronic configuration 2, 8, 1. Okay, only one electron present in the periodic table. So it can easily remove this one electron to get the stable electronic configuration. So sodium atom is the metal. But oxygen, in the case of oxygen, we know atomic number of oxygen 8, electronic configuration 2, 6. Okay, what is the electrons present in the outermost orbit? 6 electrons. So it is difficult to remove the electrons because higher number of electrons are present in the outermost orbit. Okay, nuclear charge also very high. Okay, so the increase in nuclear charge with atomic size also very low. Okay, atomics, when we are moving from left to right, atomic size decrease because the high nuclear charge increase the nuclear charge. So increase in nuclear charge tends to pull the electrons, outermost electron towards itself. Okay, so ionization energy very high. It cannot easily remove the electrons. Okay, so always it attracts the electrons because it need only two electrons to get the stable electronic configuration. With difficult to remove the 6 electron, easy to add the 2 electrons in an outermost orbit. So these top right of the periodic table elements we call as the non-metal because it always attracts the electron. It cannot lose the electrons. Understood? So this is called as the non-metal. So sodium, it is the metal, it combines with the oxygen, there is non-metal to form sodium oxide. Sodium oxide, Na2O. Na2O. Okay. So here, when sodium oxide, it is react with water. Okay, the sodium oxide, it also react with water to form sodium hydroxide. Sodium, when it react with water, NaOH is formed. That is sodium hydroxide. Okay, so here when we are balancing the equation, sodium oxide, what is the formula for sodium oxide? Na2O, because the valency of oxygen is 2. Okay, so the 2 oxygen molecule means O2. Okay, so 2 oxygen atoms are present here. Totally, how much electron need for the 2 oxygen atom? 4 electrons. One oxygen need 2 electrons and another one oxygen need 2 electrons. Totally, oxygen atom need 4 electrons. Okay, so the 4 electrons, one sodium atom give only 1 electron. Okay, so 4 sodium atom involved in this reaction. So 4 sodium atoms. Each sodium atom give 4 electrons to this oxygen atom, so it form Na2O. Na2O. Okay, understood? So for the 4 sodium we are taking here, so 2 into 2, 4. We are putting here 2. Okay, so when Na2O, sodium oxide, when it combines with water to form NaOH, how much sodium atom here? 2 sodium atom, so we are putting here 2. Okay, oxygen also, how much oxygen here? 2 oxygen. Hydrogen only 1 hydrogen, 2 hydrogens. Okay, this is the reaction between metals and non-metal. Okay, here sodium oxide react with water to give strong base. Sodium hydroxide, one of the strong base. Okay, sodium hydroxide, it is one of the strong base. Okay, so when one of the metal oxide, it form basic strong base with water, that oxide we called as the basic oxide. Important question note. What do you mean by basic oxide? When a metallic oxide, when metallic oxide combines with the water to form strong base, that metallic oxide we called as the basic oxide. Okay, another equation we have to study now. Reaction between non-metal and another one non-metal. Okay, I'm taking chlorine, one of the non-metal, and oxygen, another one non-metal. Okay, when chlorine react with oxygen to form chlorine pentoxide. Chlorine pentoxide. Okay, chlorine when combines with the 7 oxygen to form chlorine pentoxide. When chlorine pentoxide, it combines with water to form perchloric acid. perchloric acid. What is the formula for perchloric acid? HClO4. HClO4, perchloric acid. So chlorine heptoxide, what is the formula? Cl2O7. Cl2O7. Hept means 7 means hept. Okay. So chlorine heptoxide, it also combines with water to form perchloric acid. Here, what do you mean by acidic oxide? Means, what do you mean by acidic oxide? When one of the oxide when it combines with water to form strong acid, that oxide we called as the acidic oxide. Okay, here chlorine, how much chlorine atom? Here take Cl2O7. Okay, so 7 oxygen molecule we have to take here. When 7 oxygen molecule, when we are taking 7 oxygen molecule, we have to put 2 here, because 7 2s are 14. So 14 oxygen atoms here. So how many chlorine atoms here? 2 2s are 4 oxygen atom. So we should make here 2. Okay. So here how this reaction balanced? How many chlorine atoms here? 2 chlorine atom. Here only 1 chlorine atom. How many hydrogen atom? 2, but only 1 hydrogen atom here. So we have to put here 2. So what is the oxygen here? Balanced or not? Oxygen. How many oxygen are present here? 7 plus 1, 8 oxygen atoms. So 4 2s are 8. Equation is balanced. Okay. These are about the reaction between metals and non-metal, and non-metal and non-metals. Okay. And then as we move down the group, okay, as we move down the group, the ionization energy decreases and the electropositive character of element increases. Okay, as we are moving down the group, ionization energy decreases. Why? When we are moving down the group, the atomic number increases. Atomic size also increases. Atomic size, this is very, very important. Atomic size also increases when we are moving down the group. Okay, when we are moving left to right in the periodic table, left to right in the periods, atomic size also small. Atomic number increase, but atomic size decrease. Okay, atomic number increase, but atomic size decrease, because the extra electron, the new electrons is added to the same shell. Number of shells is not increased along the periods. When moving down the group, atomic size increase because the number of shells increase. Okay, so when number of shells increase, their electropositive character increase, because easily lose the electrons. Okay, because the outermost electron, the distance between center of the nucleus and outermost electrons are also increases. So nuclear force of attraction on the outermost electrons are decrease. Okay, so when we are decreasing the electron affinity on the outermost electron, so this outermost electron is easy to remove. Okay, when easily remove the outermost electron, ionization energy will be less. Okay, we have to give very small amount of energy to remove the electrons. So ionization energy decrease. When ionization energy decrease means electropositive character increase. We know when sodium, for example, I am taking the sodium atom Na 2,8,1. So when sodium atom remove the 1 electron from the outermost orbit, sodium becomes the metal positive. Okay, electropositive. Na plus electron, their electrons are deficiency takes place, the electron deficiency, because one of the electron is lost. Okay, hence the hydroxides of these elements become more basic. Okay, as we are moving down the group, the ionization energy decreases and the electropositive character of element increases. Hence the hydroxides of these elements become more basic. Hydroxides of these elements become more basic. Okay, for example, let us consider the nature of the second group hydroxides. Second group, what are the second group elements? Do you know what are the second group elements? Beryllium, magnesium, calcium, strontium, barium and radium. Here beryllium is the first element of the second group. Okay, strontium, barium, radium is the last elements of the second group. Okay, when we are moving down the group, the elements become more basic. Okay, here first, what is the first element? Beryllium. When beryllium hydroxide, what is the nature of beryllium hydroxide? Means it is amphoteric in nature. Amphoteric. What do you mean by amphoteric? Both acidic and basic nature is present. Okay, when beryllium hydroxide react with acid, it forms it react with acid as well as it is also react with base. Okay, when beryllium hydroxide it react with acid as well as base. Okay, so beryllium hydroxide is one of the amphoteric in nature. Okay, beryllium hydroxide BeOH twice. Beryllium hydroxide, when it combines with the hydrochloric acid, it forms beryllium chloride and water. Okay, BeCl2 and H2O. Okay, like that, beryllium hydroxide when combines with the sodium hydroxide, this is one of the base. It forms sodium berylate. Okay, sodium berylate. Na2 BeO2, sodium berylate plus water. Okay, by balance the equation, Be, how many beryllium atom here? Both sides are 2, only one beryllium atom. But how many chlorine atoms are present here? 2 chlorine, but here only 1 chlorine. So you have to make here 2. So how many hydrogen atom? 2 2s are 4. Here also 4 hydrogen. 2 2s are 2 plus 2, 4 hydrogen. Oxygen, how many oxygens are present here? 2 oxygen. Here also 2 oxygen. Equation is balanced here. Beryllium hydroxide, it combines with the sodium hydroxide. Here we are taking sodium berylate, means how many sodium atom is having here? 2 sodium atom. So when we should make here 2 NaOH. Beryllium, how much beryllium? Be1. Here also 1 beryllium. Oxygen, how much oxygen here? Totally here 2 plus 2, 4 oxygen atom. Here also 2 plus 2, 4 oxygen atom. Hydrogen, 2 2s are 4. Here also 2 plus 2, 4 hydrogen atom. Equation is balanced. Okay, so when we are moving down the group, metallic both basic character increases. Okay, when we are moving down the group, basic character increases. Okay, this is one of the example. Beryllium hydroxide, this is the amphoteric in nature. It both act as the acidic and basic character. Okay, when second, what is the second element of the second group? Magnesium. Okay, magnesium also weakly base, only one of the weak base. But the barium hydroxide, it is present in bottom of the second group. Okay, barium present in bottom of the second group. Okay, second group, beryllium, magnesium, calcium, strontium, barium. Okay, sixth period element, barium. Okay, second group, sixth period element. So here barium hydroxide, it is one of the strong base. Okay, so we know here, we come to know about that when we are moving down the group, basic character increases. Okay, so let me conclude here. When the elements on the left side of the periodic table has less ionization energy and ready to lose electrons during the chemical reaction. Okay, the elements present the right side of the periodic table have high electron affinity and readily accept electrons. Okay, and S and P block elements shows higher reactivity than the elements present in the middle of the periodic table. Okay, the noble gas neither accept and nor lose electrons and chemically inert. What do you mean by chemically inert? Means chemical unreactive. Okay, not reactive, chemically unreactive. Okay, and then the elements are located in the lower left portion of the periodic table has less ionization energy and therefore show metallic character. On the other hand, the elements located in the top right portion have the very high ionization energy and are non-metallic in nature. Okay, understood? And when we are moving down the group, the basic character also increases. Understood? These are about the periodic transfer and chemical reactivity. Okay, students, today's your assignment. Today I am giving 2 questions. Okay, question number 1. Compare the basic character of an element. Question number 2. Discuss the amphoteric nature of beryllium hydroxide. Okay, these 2 questions you should study and write the assignment and send me through my WhatsApp number. Very few students only are now sending, others didn't send the assignment. Okay, students should study, take notes, okay, and write the assignment. If you have any doubt, you can ask me. Okay, no problem. I will explain later. Okay. If you have book, take your book now. Page number 90 and 91. What is the first question? Compare the basic character of an elements. Okay. Page number 90, the last 2 paragraphs. You should mark now. As we move down the group, the ionization energy decreases and the electropositive character of an element increases. Okay, hence the hydroxides of these elements become more basic. For example, let us consider the nature of the second group hydroxides: beryllium hydroxide, amphoteric, magnesium hydroxide, weak base, barium hydroxide, strongly base. Understood? As we move down the group, ionization energy decreases. Okay, because we know atomic size increases, so ionization energy decreases. So metal becomes the electropositive character. Okay, so this is example. Beryllium hydroxide, the first of the second group elements. This is the amphoter, both acidic and basic character. But magnesium hydroxide, weakly basic character. But barium hydroxide, this element present bottom of the periodic table in the second group. So it is strongly basic. Okay, up to here you mark. And what is the second question? Discuss the amphoteric nature of beryllium hydroxide. You have to mark page number 90 also. The beryllium hydroxide is amphoteric. You mark this one line, one sentence. And then page number 91. Because the beryllium hydroxide reacts with both acid and base as it is amphoteric in nature. Okay. So what is the for equation? Beryllium hydroxide BeOH twice plus 2HCl gives BeCl2 plus 2H2O, and BeOH twice plus 2NaOH gives Na2BeO2. What is the name of this compound? Sodium berylate. Sodium berylate plus 2H2O. Up to here you have to mark. Okay, students, we completed the second unit, and next class onwards we have to go to the third unit. Okay, we are going to third unit. Next class onwards we studied about the third unit, unit number 3, about hydrogen. Okay, thank you all of you.